This video follows on from the video which gave an overview of how to set up a total station using the Setup app. That is, how to position and orientate the total station. This video will describe how to set up a total station using the multiple backsights method. The multiple backsights method can be used in the following case: if the point over which you will position the total station is known, and there is at least one backsight point which can be measured to. The orientation of the total station will then be computed based on the measurements to the backsights and, if desired, the height of the total station. Before completing the setup, it is possible to look at the quality of the measurements to the backsights and exclude any measurements which may be considered wrong or inaccurate. So let's run through the method. As always, move the job we want to use to the centre of the carousel. This means the setup information, for example the instrument height, the target points used and so on, will be stored to this job. Now tap on the Setup app, choose the multiple backsights method and press OK. And we access the Choose Setup Point panel. Here we can choose from where the setup point shall be selected. The options are from a job, Enter New Point, GS Smart Station and Last Used. If you choose from job, then any point from any job can be selected. This is useful since it means if your control points are stored in a different job, you can select a point from that job. Enter New Point is obvious. In the next panel, it will be possible to enter the point ID and coordinates of a new point. The GS Smart Station option is really cool. This allows the location of the total station to be measured using a GS sensor sitting on top of the total station. And Last Used Setup can be useful if you have returned to exactly the same location as the day before, for example. We will choose to enter a new point, press OK, enter the point ID and enter the known coordinates. So now we need to measure to the first target point. We can select it from the list using the point ID or select it from the 3D viewer. We need to enter the height of the target, we aim to the target and then press Measure. This will measure to the target and store the measurement. You may notice that the Calculate key is now visible. This is because we have now measured the target point and therefore the orientation of the total station can be computed. We will, however, measure one more target point. This may strengthen the orientation of the total station. We again select the target point, aim to the target and then press Measure. Again the measurement is made and the measurement is stored. We won't measure a third point but instead compute the setup. That is, calculate the orientation of the total station by pressing Calculate. Depending on how accurately the target points were measured and or the correctness of the target points themselves, we may get a message informing about the quality of the orientation. In the Results page tab, we can see the orientation which has been computed. The difference in height shows the difference between the elevation of the total station based on the point over which the total station was set up and the computed height. That is, the height based on the measurements to the target points. We can see the old and the new height and tick the box if we want to use the new height. If we want to measure to more target points, we can press Add Target. On the Setup page tab, the instrument height can be seen and re-entered if it had been forgotten or a mistake made earlier. The setup point can be given a point code if needed. The current ppm is shown as a reminder as to what ppm or scale factor is being used. On the Quality page tab, the quality of the orientation and height can be assessed. On the Targets page tab, the individual measurements to the targets can be seen. Here it is possible to change how the individual measurements are used within the computation. For example, maybe there is no height for the first target point. Maybe we only know the easting and northing and we have used a dummy height. Then we can press Use to change the use of this point to only 2D. Or maybe the second point we measured is a heighting benchmark where only the height is known. We can press Use to change the use of this point to only 1D. Or we simply measure to a wrong target point. We could remove this measurement completely using Remove. If you are using or connected to an imaging total station, then the Camera Page tab allows you to capture an image and link it to the station. In the Plot Page tab, it is possible to see a 3D view of the setup. This can be useful to visually check the setup and the location of the target points is correct. Once you are happy that all information is entered, then press Set. This will store all setup information to the job. If you are using an imaging total station, you will be asked if you want to capture a panoramic image. And then you will return to the home screen. The instrument is set up and you can get to work. The Settings panel of the Setup app can be accessed using Fn and then F1 Settings from within the app. Here you can find some useful settings. For example, if you want to measure to the target points in two faces, then tick this checkbox. If you do have a prism on any of the targets and don't want them to be found later when using a power search, then tick this checkbox. Another video explains more about this setting. In the Advanced Page tab, there are various settings which can be made. Ticking this checkbox means that once two targets are measured, the instrument will automatically turn to the next point which is selected to be measured. This checkbox allows the setup routine to be exited before it is complete, a so-called on-the-fly setup. This means the surveying of normal topo points can be started before the setup is complete. The setup points can be measured later, and once completed, the whole setup and any measured points will be updated. If this checkbox is ticked, a station scale will be calculated from the target observations. The user will have the option to apply this new scale to all subsequent measurements, including the setup observations from that setup. If not ticked, the calculated scale will not be displayed and not apply to any subsequent measurements. This checkbox means the helmet method will be used to calculate the result. Here, the default limits can be changed. If these limits are exceeded, then a message is shown when the location and orientation of the station is computed. When using the Setup app on the CS Field Controller, the F4 GS key is extremely useful if you're using a smart pole. That is, you're using a GS sensor mounted on the prism on the pole. This key then allows a point to be measured with the GS sensor, which can then immediately be used to orientate the total station. This is really useful if there are no known targets in the area. You can establish new targets using the GS sensor where it is most useful. In summary, the multiple backsights method is the method to use when you know the point over which you will position the total station and you have one or more target points to which you know the coordinates. Based on these measurements, the orientation and, if desired, the height of the total station can be computed. Please do watch the other videos to learn more about the individual methods, and thanks for watching.